Hi, Kristen McCann here. We're going to go over our rules for covalent bonding. So we're going to go over not only covalent naming, but also covalent formula writing. All right, so when we talk about covalent bonding, we're talking about a bond that's going to be occurring between two nonmetals. So again, our goal with those electrons is to be able to share electrons to reach that magic number of 8. We want a shared octet. The number of valence electrons that an element has is going to determine the number of bonds. So for example, if we had nitrogen, I know nitrogen has 5 valence electrons. So in order to reach a stable octet, it can share electrons in 1, 2, 3 different locations. For example, we've talked about hydrogen before. Okay, if I had 2 hydrogen molecules, each of those has this is a terrible example, but let's go through it because we need to cover it. Each of them have 1 valence electron. In that first energy shell, 2 is stable. 2 is a noble gas configuration. So they will share these valence electrons between them so that one element can say, hey, I have 2. I have a full stable shell. And that other element can also claim those 2 and be stable. Let's look at an example where we're actually using the full octet because hydrogen's kind of funny. It's always funny. All right, so if we have 2 chlorine molecules, both have 7 valence electrons. They're halogens. Okay, so they just need 1 more valence electron in order to complete their octet and have the stability that we see in a noble gas. So what they're going to do is they have the ability to create 1 bond. Okay, so they're going to share those 2 electrons. So this chlorine has 1, 2. I'm going to do a different color so you can see it. 1, 2, 3, 4, 5, 6, 7, 8. And the other chlorine gets to claim those shared electrons too. So he has 1, 2, 3, 4, 5, 6, 7, 8 total electrons. So sharing is another way to get up to that stable level, to that octet of electrons. All right, so let's talk about how to name these covalent compounds. Your first nonmetal is named as is. So you're not going to change anything about the ending on that. Your second nonmetal is named, and you'll change the suffix to IDE. So for example, as we've done before, if you have bromine, we change that ending. We keep the stem, and we change the ending to bromide. Okay, so we change that end to IDE. We're going to use prefixes to indicate the number of atoms that are present, and we look at the subscripts that are right after the element symbol in order to determine what my prefix should be. All right, so you're going to have to pause me on this one. This is a very long list that you need to know. You will be responsible for knowing the prefixes for 1 through 10. So if we have an element that has, say, only 1, or no number in the subscript, such as what we see right here with CO. Okay, we're going to assume 1. We would use mono. Now, mono is kind of funny because you would never start the name of an element with mono. So I wouldn't say monocarbon. I would say carbon monoxide or monoxide. Di is for 2. Tri is for 3. These are kind of the easier ones, starting with tetras where it gets a little weird. We don't say quad or anything, we say tetra. I like to think of Tetris blocks. Each of the Tetris blocks in the game are 4 blocks that make different shapes, so 4 is tetra. Penta, you can think of a pentagon being 5-sided, that's 5 for your subscript. Hexa is 6, hepta is 7. These two often get confused with one another. I like to remember that the word 6 has an X in it, just like hexa, and then the other one's 7. I don't have anything good for hepta. Octa, you can think of an octopus, has 8 arms. Octa is 8. Nona, or nana, is 9. And deca, think of a decathlon, is 10. So those are ones that you're going to have to commit to memory so that you'll be able to name covalent compounds. All right, so we have kind of a funky rule. Sometimes when you're using your prefixes, you may have 2 vowels that are going to wind up right next to each other in a name, and it becomes kind of awkward to say it. So when your prefix and the element name place 2 vowels next to each other, you're going to drop the first vowel. So for example, if or let's just say I had 5 oxygens, I would say penta. Okay, just like you see here, penta, and then oxide. Okay, the problem is I'm placing these two vowels right next to each other. So I'm going to drop that first vowel, and I'm instead just going to continue with my word, oxide. So it's pentaoxide, not pentaoxide. It's kind of a funky rule you'll run into. And the more you do this, the more natural it's going to feel when you're saying it. Let's go through some examples. All right, SF6. Well, according to my subscript, and there is no number here in my subscript, I have 1 sulfur. As our rules tell us, I'm not allowed to say monosulfur. I just simply say sulfur. And then I move on to the next element. The second element is fluorine, and I have 6 of those. My prefix for 6 is hexa, so I'll say hexa. Fluor, and then remember that we keep the stem of fluorine and we change the ending to IDE. So this becomes, from fluorine, becomes hexafluoride. All right, let's do another example. NO3, again, I have 1 single nitrogen molecule. I'm not allowed to put mono on the first. I can put it on the second all I want, but you can't put it on the first. So this is going to be nitrogen, and I don't change the ending of the first element. I have 3 oxygens, so the prefix for 3 is tri, and then I take oxygen, I take the stem out of that, and we've talked about that before. It's one of those weird ones, and I just keep the OX, and I drop the Y-gen, and I make the word oxide. All right, CO. I can't say mono on the first. These are all mono examples on the first. So I just start with my element. Because it has no prefix, remember that it is assumed that you only have 1 of those. So I have 1 carbon and 1 oxygen. So I'm going to say monox, and then I change my ending to IDE. Now remember, mono and oxygen are going to place 2 vowels next to each other. So I'm going to drop one of those O's, or else it looks really funny. You're like monoxide, and that's just silly. So I drop one of my O's and I put monoxide. I change that ending to IDE and I keep the stem.